The first lesson of our unit is having us think about the meanings of division. So the very first problem here is, what are some different ways we could think about 20 divided by 4? Now the next slide actually gives us a whole bunch of different ways we could think about it. We can be thinking, how many groups of 4 are in 20? Or if there's 4 in each group, how many groups are there? How many 4s are in the 20? What is 1/4 of 20? That's like we're breaking it into quarters. So lots of different ways that we could be thinking about this expression. Now if I go to the next slide, we have how Claire is thinking about 12 pounds of almonds being put into bags so that each bag has the same weight. Here's the diagram that she drew thinking about 12 divided by 6, and then how would we interpret that in this missing piece. I think that Claire was thinking about taking the 12 pounds and splitting it into 6-pound groups, and she ended up with 2 groups. So my missing number here would be 2 times 6 equals 12, or 12 divided by 6 equals 2 bags in this case. So I think that's how Clara was thinking of it. She was thinking about putting 6 pounds in each bag, and her quotient here would be 2 bags. Whereas Tyler thought of this problem a different way. I feel like Tyler's looking at it as 12 divided by 6, dividing it into 6 bags, and this time our missing value is the 2, meaning 2 pounds in each bag, each of the 6 bags. So we get that same quotient of 2 for both situations, but they're definitely thinking about them in different ways. On slide 6, we're being asked to think about different division problems here. 12 divided by 4, I chose to divide this into 4 bags with 3 pounds in each. That's one way to have done this. You might have taken 12 divided by 4 and made 3 groups with 4 in each, or 3 bags with 4 pounds in each, and that would still be correct. If I go to the next slide here, then I'm thinking about 12 divided by 2. I thought of this one as 2 pounds in each bag, and that would make 6 bags for us. You might have thought of that in the reverse, where you maybe had 2 bags with 6 pounds in each, and that would also be correct. This last one was hard to draw because I thought of it as taking the 12 pounds and putting a ½ pound into each bag. How many bags would that require? And it required 24 bags for me. So there's a ½ pound represented in each of these, which was obviously a challenge to draw. On slide 9, we're talking about taking a loaf of bread, so that would be our one whole thing, and cutting it into slices. Well, if each slice is half of a loaf, how many slices would there be? Well, that would just be 2 slices. Half plus a half would give me the whole thing. If each slice is a fifth of a loaf, there would be 5 slices. 1/5, 2/5, 3/5, 4/5, 5/5 for the whole thing. So what happens to the number of slices as each slice gets smaller? Well, we got a smaller slice here, but we ended up with more slices. Our number of slices is increasing. What would it mean if we were trying to divide by 0 here? And I said that would be impossible. You can't have 0 slices of a loaf. You would at the very least have the whole loaf, but I can't have 0 slices and be dividing by 0. That would be impossible here. If I go to slide 10, here's 3 possible ways we could think about 20 divided by 8. Could be 20 divided into groups of 8, 20 divided into 8 groups, or something times 8 is 20. So then we're going to try to draw those out a little bit. If we're thinking of it as how many groups of 8 are in 20, well, here's my group of 20, and this is just one way to show it. You may have shown yours differently, but I showed here's one group of 8, 2 groups of 8, and I couldn't get a whole nother group of 8. I couldn't get a third group, but I could get half of a group. So 2½ groups of 8 would be my quotient here. Whereas if I think of it as how much is in each group, well, at first I took my 20 and I divided by 10. There were 2 in each group, but that was too many groups. I had to take these 4 at the end here and divide those equally between my 8 groups. So now I've drawn my diagram with just 8 groups, and there would be 2½ in each. And if I add that 2½ up 8 times, I will get my total of 20. On slide 14, the multiplication problem here would be something times 8 is 20. Yes, both of my previous diagrams work for this. They both show that something times 8 is 20. They both show that 2.5 times 8 is 20 in their own ways. So those would all be equivalent, meaning they're talking about the same situation. If we have 60 students that we're trying to put into equal size groups and we look at 60 divided by 5, well, it could mean that we're putting the students into 5 equal groups. It could also mean that we're putting 5 students in each group. Either way, the quotient is 12, which could mean there were 12 students in each of the 5 groups, or there could be 12 groups with 5 students in each. So 2 different ways we can think about that division problem. So division always has a couple different ways to view it. Looking at this division expression, 7.5 divided by 2, the only multiplication equations that matched would be 2 times something is 7.5, or we could use our commutative property, something times 2 is 7.5. None of these other multiplications would be in that same fact family. And that was the end of the lesson on meanings of division.